for number 8, we talked Friday about how there's sort of 3 different ways they can give us information, right? They can tell us what the slope is. They can give us 2 points, and then we use the slope formula to find the slope, or they can give us a line that's like parallel or perpendicular. So which one of those are we, which situation are we in here in example 8? What information they gave us. So did they give us the slope? Did they give us 2 points, or did they give us a parallel or perpendicular line?
Is that 2 points?
Mm-hmm. Yeah, so they told us where it intersects each axis, right? Mm-hmm. So each of those is a point. We can write them as ordered pairs. We know that any point on the x-axis has a y-coordinate of 0, and so this first one is 4, 0. And then any point on the y-axis has an x-coordinate of 0. So the second point is 0, -6. And the nice thing about this is they actually gave us that y-intercept, right? So we know what b is, and we don't have to do quite as much work to get our equation. Because once we have the slope, we can just put it directly into slope-intercept form, since we have that b already. So we'll find our slope. M equals 0 minus -6 over 4 minus 0, which is 6/4, which gives us 3/2. So now we have both m and b. So if we were to do this as if we didn't know what the y-intercept was, it would all work out exactly the same way. So if you set 3/2 equal to like y minus -6 over x minus 0 and do the whole process, it would still work. But because if you can notice that they gave you the y-intercept already, you can save yourself a little bit of work. So this is just y equals 3/2 x minus 6, and we're done. And that's just because one of the points they gave us had an x-coordinate of 0, and that's how we knew that was our y-intercept. And we got b straight from that. Good? Okay, so number 9. So just like we've done with all the other application problems, we're going to start by just labeling everything. So identifying what our inputs and outputs are, what variables represent each, what the units are for each. And that way we can keep coming back to that as we answer each one of the questions instead of having to try to like start all over and figure everything out from scratch every single time. So we're going to start with our input and output. So when a function is given in function notation, so like with the e of t on the left there, what is in these parentheses is always your input, no matter what. Also notice it will always correspond to the variable that's in the formula. So even if this wasn't in function notation, like if it said y equals, I would know that t was my input because it's what is in the expression on the right side where I'm actually doing the calculation. So your input is the thing that you end up doing calculations with to get your output. So my input is t, and then I look through the problem to figure out what t represents. So right after my function, it says t is the number of years since 2003. So number of years since 2003. And then again, when it's in function notation, that entire left side of your function is always your output. So e of t and when they tell you what your output represents, they often don't say it in quite as obvious a way as they do with the input. Like with the input, they literally just said T is the number of years since 2003, right? With your output, they're not quite as clear, but whenever they say that something is modeled by a function or that the equation gives something, that's what your output is. So here it says the life expectancy is modeled by that function. That means that the function gives an output of the life expectancy. And so whatever it is that your function is modeling, that's what your output is going to be. So E of t is the life expectancy and that's measured in years. T years after, or since, I guess is the word they used here, since 2003. Okay, so now we're going to start with interpreting some of the numbers in the function itself. So let's always start with just what the number represents in terms of an equation. So in terms of a linear equation, y equals mx plus b, what is that 0.35? It's my slope, right? So 0.35 is the slope. And remember that slope is the change in the output over the change in the input. So if we take this 0.35 and just write it kind of like a fraction, so 0.35 over 1, then I can start just matching units. So in the numerator, that's the change in the output. So my output is measured in years, right? This one's a little tricky because the input and output are both measured in years, right? But the output is measuring life expectancy, so it's like years of age. So we'll write years of age, just to remind ourselves which is which. And then our input is measuring years, like, of time passing. So what this tells me is that the life expectancy, my output, increases, and the reason I know it's an increase is because my slope is positive. 0.35 years every year after 2003. So for each year that goes by after 2003, the life expectancy increases by 0.35 years. So far, so good? Okay, what about that 46.56? What does that represent in my linear equation? So just in terms of the equation.
That was the life expectancy in 2003?
Right, so that 46.56 is my y-intercept, right? So I know that it corresponds to an input of 0. So I can say E of 0 equals 46.56. And this is where, like, if you're not sure what that represents, if you can write it like this and then go back up to what you wrote, where it says E of t equals life expectancy t years since 2003, you could literally, like, copy that and then just replace the t with 0, right? So 46.56 is the life expectancy 0 years since 2003, which, I mean, I might not actually write 0 years since 2003 because it sounds a little silly, but then you can condense that into in the year 2003, right? So 46.56 years is the life expectancy in 2003. Okay, you guys try C and D. Is correct, so make sure that when you're evaluating your functions, you have two sides, right? E of something equals in every step. And this one, you didn't have to write like a big long sentence or anything, since it doesn't ask you to interpret it, but be sure to put units on it at the very least. And then for D, they've given us the output, so E of t is equal to 60. So that's saying set the entire function, so the right side of that, equal to 60. So we have 60 equals 0.35t plus 46.56. And what'd you guys get?
38.4.
38.4. So, good. And if you said 2042, that would be okay too. They never specify if it's since the beginning of 2003 or since the end of 2003. So like, you know, if you say it's been half a year, is it like half a year into 2004 or is it half a year into 2003? I don't really know. As long as you show your work, I don't really care. Any questions on that one? Excellent. So I've got more notes for you. Since these are really the same problems, we're either given the slope and a point, or we're given 2 points. In this case, they're not going to give us parallel, perpendicular, or anything like that. So it's really you just want to know if you're given 2 points or if you're given the slope and a point. And from there, once you know those things, then you can write the equation the same way we did on Friday. So we'll start just like we did with the last one with what our input and output are. So input and output. So that very last sentence, or even just the last half of the last sentence, is language that you'll see a lot. This idea of something being a function of something else. So if you think about like function notation and the way we read it, like when I write f of x, I say of x, right? So I say f, which is the name of the function, of whatever the input is. And so when we write it in words, it's the same way. So when I say we're going to write p as a function of the quantity, we're saying the quantity is the input, and then p is the output. So whatever it's a function of is always your input. So in this case, our input is q, which is the quantity of mugs. And the output is p, which is the price per mug. The idea here is, so we're writing what we call a demand equation, which is the relationship between how much something costs and how much consumers are willing to buy. So we kind of know, like common sense wise, that the more things cost, the less people are willing to buy. So it makes sense for this to have a negative slope because they're going in opposite directions, the quantity and price. So whenever you write a demand equation, you should get a negative slope, and that's just something you can kind of keep in the back of your head just to double check that you didn't drop a negative somewhere. Are we given 2 points here, or are we given a rate of change and 1 point? Yeah, we're given 2 points, right? Because they give us 2 pairs of quantities and prices. So we know that our points are going to look like QP and we're told that when the quantity is 31, that corresponds to a price of 18, and that a quantity of 23 corresponds to a price of 24. And now we're right back where we were on Friday, right? We have 2 points, we can find our slope, and then we'll write an equation. So M equals 18 minus 24 over 31 minus 23. I'm going to go ahead and write that as a decimal because we're talking about money and also because the decimal ends. It's not a repeating decimal, so I don't have to round in order to write it as a decimal. So then we have negative 0.75 equals P minus 24 over Q minus 23. If you really, really feel like using X and Y, like, is totally essential to your way of life, that's okay. You just need to remember to change it at the very end so that your final equation is in the variables that are given in the problem. I find it helps to write that point, the QP, at first so that I remember which one is my X and which one is my Y if I'm going to switch back and forth later so I don't accidentally replace the wrong ones. So we'll clear fractions. Distribute. And add 24 to both sides. So P equals negative 0.75Q plus 4125. Make sense? Yeah? Okay, we're going to skip to number 12 because it's similar to the one that we just did. So in this one, it seems like they give different information, but they're really just giving it in a different way. Like when they say, so they give us the fact that if 30 people go on this tour, they charge $10 per person. And so that's one point, right? And then they tell us for each one person above the 30-person level, the charge is reduced by 20 cents, which is really a rate of change. And if you want to, you can use that as your M. Then you just have to figure out how to fit it into the equation. I find it easier just to use that information to fill in the table and then use 2 points from my table exactly the same way we just did the last problem. And that way we don't have to try to like interpret that whole one person reduced by 20 cents as like a rate of change. So if we increase the number of people by one person, then the price is going to decrease by 20 cents. So the price will be $9.80. And if we increase by one again, it's going to decrease by another 20 cents, which will be $9.60. And then we increase to 40, which is more than one person. So I'm just going to wait till I write an equation, and then I can plug that 40 into my equation and figure out what the price will be. So at this point, we're exactly where we were in the last problem. So we have our input, which is X, and that's our quantity. I know this because that first column says that the quantity is X. And then our output, they don't give me a variable to use, so I'm just going to use Y. And that's going to be my price. And now you have 3 ordered pairs, so you can pick any 2 of them. So you can use 30.10, 31.980, 32.960. Any 2 of those 3 ordered pairs, you'll use exactly the same way we did in the previous problem to write your equation. So go ahead and write your linear equation that models the price. just for part B, and then we'll do part C together. Okay, let's go back to, or no, let's go to 13. You definitely have one like this on your homework. Okay, chicken pens. I don't know why 121 instructors like to build enclosures for animals so much, but they come up a lot. So we're going to construct a model that gives the amount of fencing that we need to build the pen, shown here, when X is the distance as shown from the side of the hen house to the corner of the pen. So just to be clear, Rebecca does not need any fencing right here, because if you put up fencing there, then they wouldn't be able to get from their pen to their house to lay their eggs. So we just need fencing around the outside of the pen. So these problems, I always start just by labeling everything. So I'm going to label all the sides that are going to require fencing, and that way I can just add them all up. So let's start with this length here. From here to here, what is that length going to be?
20x.
So it's going to be 20 plus x, right? I'm going to add them. Good. One thing that can help with operations is when you're going along like the same direction, like along a single line, you're always adding or subtracting. The only time you'll multiply is if you have different dimensions. So if you have a length and a width, you multiply those to get your area. But if you're going along the same like single line, you always add or subtract lengths. So then we want the width to be half the length. So this is going to be just 1/2 of my length. And this side will be exactly the same. So now all we have to do is add that all up. So F, which represents the total amount of fencing I need, is equal to, well, I need this length, which is X, plus this, which is 1/2 20 plus X, and then along the bottom is 20 plus X. And then back up to our hen house is 1/2 times 20 plus X. One thing I notice when I look at this is that I'm adding 1/2 of something plus 1/2 of the same thing, which is the same as just having one of them. Does that make sense? So I can write this as F equals X plus 1 times 20 plus X plus 20 plus X. And then I don't have to like actually deal with those fractions, which is kind of nice. So we end up with F equals 3X plus 40. So now we're going to use that model to determine the amount of fencing for the pen if its length is 60 feet. So my length is 60. Where is my length on the diagram? Yeah, it's that bottom length right there, that 20 plus X. So this is equal to 20 plus X, which means that X is 40 here. Right? So sometimes we have to be a little bit careful not to just start throwing numbers into our equation. Make sure that the X value that you're putting in your equation actually represents what X represents in the problem. So here our X value is 40. So now we have F equals 3 times 40 plus 40, which is 160 feet. Okay, you guys figure out what the dimensions should be if she has only 100 feet. Remember, dimensions are length and width. So when you get to the very last step of the problem, once you've solved for x, your goal is to find the length and the width of the chicken pen. F equal to 100, and we solve. So we have 100 equals 3x plus 40. And that gives us x equals 20. And then we just go back up to our diagram, and we're like, oh, the length is 20 plus x. And so my length is going to be 40. Feet. And then the width, you can either use that formula 1/2 20 plus x, or you can just remember it's half the length. And so half the length would be 20 feet. So our width is 20 feet.
So you just have to forget about that x on the top though, because the length can't be 20 on the top as well. It'd have to be half, like, it only be 20 on the top.
Well, so this isn't the length. Like the length is all the way from here to here.
Okay, I guess I'm confused, because you don't have to have the 20, you don't have to, part of it doesn't even have to be fenced. So you just have to forget about the top, or you're not, like it doesn't change your dimensions then?
Right, exactly. Like since the shape of it is a rectangle, like the dimensions of a rectangle are just the length and width of the rectangle. So that's all they're asking for, is like the rectangle that you end up with, what's its length and width. Okay, so